Hey guys, thanks for clicking on my video. Hopefully I'll be able to show you guys some pretty cool things. The reason I made this video is because I'm putting together, some projects that I just do on in my spare time, and I wanted to learn the dash mechanic. And while trying to research and find what works best for what I wanted, I watched a lot of YouTube videos on dashing, and there's a lot of good ones out there. But I decided to put this video together because there are no videos out there that I could find. Correct me if I'm wrong, please. All right. I couldn't find any videos that showed you how to do the dash mechanic from the sit still, from the standstill. Every video out there was already where the character was already in motion when they did the dash. And so now, if you can see here, I'm dashing from the standstill. And the other thing is that I couldn't find any videos that used the new input system, Unity's new input system. And so I wanted to also implement the new input system with the dash mechanic. Seems like there's a lot of tutorials out there that are still using the old input system. So anyway, hopefully this will teach or help somebody, even if it just helps one person. Then I will have accomplished my goal. So let's get started with a brand new project here. I'm going to just open up a brand new project here. Let's close that one out. Okay. So first, when you open up a new project, you will have to install the new input system, which you do by going to Windows, Package Manager, click on Package Manager, okay, and then you go to Unity Registry on the drop down here, Unity Registry, go down to Input, System, boom, and then import it. So I've already imported it on this project, but then you click import. Then another box will come up, and you can either click yes and it'll restart it, or click no and then it'll still install it, but then you have to go and change the input settings. Anyway, this tutorial is not gonna be about the new input system, or it's not gonna be exclusively for the new input system. So I'm not going to explain the new input system. I'm just going to use the input system and show you how to implement the movement, jumping, and dashing using the new input system. All right, so let's create our scene here. Let's create a player object. Call it player. I'm not going to be doing all the nice art assets that I showed you in the beginning of this video. I'm just going to go through the basics. And I'm going to try to do this quickly so that you don't get bored. Anyway, we got a player. Now let's create a ground. By the way, this is, I don't know if I mentioned it, this is my very first ever YouTube video. So please leave me a comment on how I did, or what I could do to improve, or anything like that. Not looking to become famous or anything, or even popular. I'm just making this video to hopefully help some people out. So let's go up to camera. Let's increase the size real quick. Okay, take our ground object, just kind of make it bigger. Let's do 20. No, let's do 30. Okay, now with our player, because we're going to be implementing a flip as well, I want to show you the flip as well. So let's make an eyeball so we know which way we're facing. We'll do a circle. We'll call it the eye. Change the color to black. And then Let's add a sorting layer for player. Okay, and we'll put the eye. No. No. Let's take the player, move him down. Okay. Let's add that eye now. Sprite, circle. Let's change the color to black. Let's change the default layer as well to player. And then on the order and layer, we'll make it 1 to make it come out before the player. And then let's change the size. Just to make it look like an eye. Put it up here in the corner. Yeah, that works. All right. Oops. Whoops. Just trying to change the name here. Okay. Anyway, so that's the eye. And then we need to, for the ground, because we're going to be jumping, we're going to need to have a ground layer, which I've already made. So let's add that. Let's see. So we got the player, we got the ground. Oh, so on the player we need to add the components. We need to add box collider, physics 2D box collider, and then as well as a rigid body for movement. Yeah, boy. All right. And on the ground, we need a box collider so we don't fall through it. Okay. So let's create a folder called Input System. And that's going to be where we put our input system asset. So let's open that up. And so we need to, in order to use Unity's new input system, you need to create a input asset. So you go to create, all the way down at the bottom, input actions asset. Call it whatever you want. I'm going to call mine input, player input actions. Okay. And then we will open that up. We'll just double click it. We're going to add an action map called player. There's a lot of great YouTube videos on it goes into depth on the input system and what things are and all that. I'm not going to go over any of that. I'm just showing you step by step how to do it. So then we create a new action. We're going to rename this one as movement. We need to be able to move. Let's delete this binding. Now our movement is not going to be a button, it's going to be a value, and it's going to be a value of type vector2. So we need to add, we're going to do a 2D vector movement, we'll call it WASD, and then we're going to bind our keys, listen, do W for up. Even though we won't really ever use up or down, but we'll still assign them. Down will be S. Left will be A. And right will be D. All right, so that completes our movement. And normally I would also add a controller on here. That's the whole point. The whole point of the new input system is to make it easier to switch between controller types, along with a couple of other things that make it easier. But since you can't visually see me using the controller, I'm not going to add the controller. I'm just going to do WASD, just for the purpose of time. All right, so we got our movement done. We will need to add another one. So click add. We're going to do this one for jump. The jump is going to be a button, so we're going to leave that as is. We're going to assign it to the space bar. And then we're going to add a third one, and we're going to call this one dash. And again, dash is going to be a button. And I like to use, for my personal preference, is the right mouse button. So instead of clicking listen, because you can't click listen and then type, oh wait, yeah, you can, look at that. All right, cool. Right mouse button. Why wasn't it letting me do it before? All right, anyway, so right mouse button is what I use for dash. And we'll save the asset. And that's all you got to do to set up your bindings and your actions. So now back to player, we'll need to add another component to the player called input, right here. Player input. We're going to change the behaviors right here from send messages to invoke Unity events. And you will see on the, oh wait, no, we got to do player input, put it in here. So drag that actions map into the actions slot. And then under events, you will see player. And you'll see what we did here. Movement, jump, and dash. Okay, cool. So we're going to now create a new folder. We're going to call it scripts. And then inside the scripts folder, create a new C# script called player movement, or call it whatever you want to call it. Call it this script. I don't care. Whatever works for you, man. All right. Then we're going to open that up in the IDE, reload. And when you use the new input system, you got to have the namespace using the Unity engine input system. So add that namespace up top. And then let's go through. Now I've already done this project, so I'm going to be copying from my own script. But it's just something for me to look at while I go through it. I like to keep things organized in all of my scripts. So I like to use headers. So we're going to do a header for movement variables. Movement variables. All right. So we need a reference to the rigid body. Private rigid body, since it's a 2D game, you go rigid body 2D. And the standard across most coders is just to do RB. And we need a reference to our vector 2. We're going to call it move vector, because the vector 2 is how we're going to move. So we're going to call it move vector. We'll end up needing a jump float, so that'll be public, so that we can change it in the inspector. So that'll be public float jump distance. We need a speed. That'll also be public, so we can change it. And then we'll call it move speed. We'll need a bool for if we're facing in the right direction. I like to be able to see the bools activate, but it doesn't need to be public. So in order to see it in the inspector when it's not public, you have to use serialized field. that allows you to leave a variable as private, but still be able to see it. Alright, we're not going to do double jumping in this tutorial, so I don't need that. I don't need that. Let's see. Okay, let's just move on to our ground check. Header. Ground check. This is just to keep it organized. You don't need to do headers. But it's a cool thing to get used to doing because it helps keep things organized. So, so is grounded bool, we need that. And again, you know, the is grounded bool doesn't need to be public, but I still like to see it so I know that it's working. So anyway, so we'll do, again, serialized field allows a private variable to be seen in the inspector. We will need a reference to our to a ground spot that we're going to use to detect if we're grounded. And we're going to call it ground spot. And then our layer mask. This is all pretty standard across all coders. This is pretty much the standard of how you do ground checking. Layer mask. Call it ground layer. Most videos out there will call it like what is ground, or you call it whatever you want. I call mine ground layer. And then for our dash mechanic, we're going to have some variables. Header. Dash variables. Sorry, getting down there. Let me move it up. So our dash variables will be, these are all going to be serialized fields because they don't need to, some of them. But I want to be able to adjust some of them. Anyway, serialized field, bool, can dash. We're going to default that to true. Serialized field is dashing. Serialized field dash power. Oh, oops. That's a float. Serialized field for dash time. We need a serialized field for our cooldown, or a float for our cooldown. Let's see, what else do we have? Oh, our trail renderer, so that you have a visual. So that doesn't even, we don't even need to see that. So we'll do private trail renderer dash trail. Now we'll do a serialized field for private dash gravity. And so we're going to have a dash gravity that's going to be different than our regular gravity. And that you will see here in a bit. But so we're going to have a normal gravity, and that's going to be whatever you assign in the inspector on your rigid body. And we're going to have a wait time. Let's see, private float wait time. This will all make sense. But I'm trying to make this not like an hour-and-a-half long video. We're not going to do animations. All right, so let's assign our variables. In our awake function, we're going to get a reference to the rigid body. Get component. Oops. rigid body 2D. Our dash trail is going to be get component also for the trail renderer. We're going to assign our normal gravity variable equal to whatever you assign as your gravity. So it's going to be the rigid body's gravity, and that's going to be whatever your normal gravity is, and you'll see why we have to have normal gravity here in a bit. And then our bool for is facing right is true. All right, so let's move immediately to doing our movement. And let's get that set. So we're going to do... Okay, so this is using the new input system. Public void move. You'll see a lot of videos out there that do like on move. You don't need to do on move. You just do move. But it does have to have the parameters for the input actions map. Input action dot callback context. Again, I'm not going to explain all of it, mainly because I wouldn't be very good at explaining it. Everybody has a different learning technique. I learn from doing, hands-on. You know, some people can learn better by reading. Anyway, so I wouldn't be very good at explaining. It's like one of those things where I just know what to do because I've watched a lot of videos. So move vector. So this is a reference to our move vector a variable up here that we assigned. Right there. So we need to, on our move function, we need to read that value. So move vector is going to be equal to our context dot read value, and the value we're reading is a vector 2. Okay, and that's all you do for that. So that's our movement. And then, as everyone should know, you should know that all physics-based movement should be done in the fixed update, not in the normal update. So we're going to do void fixed update, and when we call the move function, we're going to move our player. We're going to use this move vector, the value that we're reading from it. We're going to use that to move our character. So we're going to say rigid body dot velocity is equal to new vector 2, and we're going to move along two vectors, an x or an y. We're going to say whatever our value is that we're reading on the move vector dot x. We're going to move in that direction times our movement speed, and we're going to leave our y alone. So we're going to just rb.velocity.y. And that is it for basically for being able to move using the new input system. So right here we read the value, right here we move. Pretty simple. Let's go back, and because I made everything serializable, we can start going through them. Oh, let's put the player movement script on the player. Duh. And actually I want to put it right above the input. Come on. There we go. I like to move it above the input there. So you see this gravity scale on your rigid body is 1. I'm going to be changing that. Actually, I'm going to change it to 2 right now. Because like I said, I've already done this. And I know that 2 is a good gravity for the jump height that I'm going to do. So on our movement, I know my jump distance is going to be 10. My move speed, a good one is 8. Our ground layer is ground. So let's go, okay, ground spot. So here, see, we need a transform for the ground spot. So let's make that. Right click, create empty. Every game object has a transform, but you don't need a sprite or anything for the ground spot. We're going to call it ground spot. We just need a transform, so it can be an empty game object. But I do want to visually see it. So we'll use a little tag there. Go down negative 0.5. So let's assign the ground spot right there. Boom. Now our dash power I know was 30. The dash time is going to be representative of how long you want to be able to dash. The cooldown is the amount of time between each dash, so that you're not spamming it. Unless you do want to spam it. If you want to be able to spam the dash, then your cooldown should be 0. But for right now, for this tutorial, it'll be 1 second between dash. And then the reason we made the dash gravity as a serializable field is so that you can change it as well. So if you want your player to be able to dash in a straight line, you'll leave it at 0 so that there is no gravity while he's dashing like in the air. Otherwise, you can add some downward force if that's what you want for the mechanic. Okay, so we've added our variables. We've put them in here. Now we need to assign the movement variable to our player input. So we go to events. Remember, we changed it to invoke Unity events. So we go click on player, and under our movement here, we're going to add the player movement script. Click and drag it into that slot there, and then assign a function, player movement, move, right there. Boom. So now if we push play, we should be able to move. Okay, just like that. So you can move your character. You can change the speed, move speed, you know, slower if you want, faster. It's up to you. So, all right, we got the movement working. Let's go back. Let's do jumping now. So right underneath move, we're going to do public void jump. And it's also going to take in input actions, callback context. Now, unlike move, we're not reading a vector2 value, so we don't need to read anything. We're just going to go straight into assigning the movement value inside this function. So if you recall, if we go back here to our input system folder, open up our player input, whereas movement, the value is a vector2 that we had to read. For jump and for dash, you can see they're both, the action type is a button. So that's what we're going to do in the code. We don't have to read a value, but we have to know if the jump button, which we assigned as the space bar, if that jump button has been pressed. So in order to do that with the Unity, the new input system, we say if context dot perform, and then obviously if you know about jumping, you have to be grounded. So if is grounded is true. We don't want to be able to jump if we're not grounded. So for our jump, we're going to set our velocity, our player's rigid body's velocity equal to a new vector2. And for the x, we're just going to leave it as whatever it is, rb.velocity.x. And then for here, we're going to do just our jump distance. And that's going to represent the y value. Now, we can't jump, well, right now this code is done for the jump function, but we can't jump because we have to declare if we're grounded or not. So is grounded is always done in the update function. So void update, and we're going to say is grounded is equal to physics 2D, and we're going to use the overlap circle. And you can see it takes in vector 2 and a radius with some overloads. So that vector 2 is looking for basically a spot that it's going to overlap with the ground layer, if that makes sense. See, I'm not very good at explaining things. I'm more of a just I know how to do it rather than know how to explain it. But this video is like me trying to break that habit. I want to try to see if I can explain things to people. All right, so overlap circle, it's going to take in a vector 2, which is the ground spot that we declared up top. That ground spot is a transform. That's what we created on our player here. Let it update. All right, so this is what it's talking about, that ground spot. And then it'll take in a radius, and a small radius is really all you need. And then a layer mask. See, it also has a layer mask that you can put in. And that layer mask is what we did up here, that ground layer. Basically, you have to know if you're touching this layer. And what layer are we touching? Well, it's called ground. If we are touching a layer mask called ground, then we are grounded. Oh, yeah, and since it's a vector 2, it has to have a position. Sorry. Okay. Let's see here. So if we're grounded, then we can jump, right? Right here. So that should be it. Let's go back to the game. And now we should be able to jump. Move. Oh, wait. Hold on. I missed something. Ground layer. Oh. You know what it is? I bet you guys are like, oh, dude. You gotta assign it. See right here? We didn't assign it. Okay. So bring on the script, go over here, assign the function for player movement. You'll see at the top here, jump. And now we should be able to jump. Eee. So you can tweak these values in the inspector. That's why I labeled them as some are public or some are just serializable. Let's see, where is it? Jump distance 10. That's why, so if you leave the rigid body's gravity as its default value of 1, you can see it's a really floaty jump. And we don't want that, or I don't want that. If you want that, then that's you. But I didn't want that, so I had to play around with it. So gravity scale 2 with a jump distance here of 10 gives a pretty good jump. Anyway, play around with that as you see fit. So now we've got our movement and we've got our jump. Now let's go into the dash, the whole reason for this video. Like I said at the beginning of the video, I was not able to find a YouTube tutorial on how to dash from being still, sitting still, as well as a video that used the new input system to do it. So just like with our jump, we're going to implement a dash, and we're going to call it public void dash, and it's going to take in the input actions dot callback context. Now, it's not exactly like the jump. We still have to read has the dash button been pushed, but we're not. We cannot assign the value or the movement of the dash inside the function. So we're going to call a function. Now, here's where this is exactly where I could not find anybody that did this. Okay, so a lot of the YouTube videos out there are using IEnumerators and coroutines to do a dash mechanic, and that works. That does work. But from a few of the videos that I watched, like I said, I couldn't find one that did it from the standstill or that used the new input system. So here we go. We need to determine if the button for dash has been pushed. So that's what we're doing with context.performed. Has the button been pushed? Now, once the button has been pushed, we have to determine, are we able to dash? Can we dash? Okay, that Boolean is either true or false. Now, if it's true, then we have to do a nested if statement. If our wait time, okay, now this is going to be time.delta time. Basically, after we dash, we're going to set this wait time back to 0. But if our wait time, which is time.delta time, is greater or equal to our dash cooldown, right? That's the second that we assigned, because we don't want to be able to spam the dash. So we want to have a cooldown between each dash. Then after that, we're going to set our wait time back to 0. So we start over again, counting up. And then because I didn't want to do things the way that I saw it on the YouTube videos, I'm doing an invoke dash. So I'm invoking a dash function after 0 seconds. But I want to show you what I learned from the start coroutines. Okay, so if let's just comment this whole thing out, actually. Oh no, not that. Let's comment this section out. Okay, so I'm going to show you the coroutine from a YouTuber named Bendux. Bendux, man, if you see this video, let me know if I'm saying that right, because I don't think I am. But start coroutine, so dash, and how was that done? So we got to create a dash function, IEnumerator. So IEnumerator called dash. All right, now I'm going to put in this guy's website because I want to give him credit. I don't want anyone to think that I'm plagiarizing. So here is his website. So again, his name is this code is from Bendo at website. All right, so you can go to that website and see his video. It's a good video, but this is what he does. And the reason I'm showing you what he does is because I want you to have some backstory as to why I had to do what why I wanted to make this video. So He does the numerator here with can dash. He sets it to false. He sets is dashing to true, because if you're dashing, right? If you push the button. What does he do? Okay, so in his video, he goes. He has a float for original gravity, and he sets it equal to the rigid body's gravity scale. Cool. Then he sets the rigid body's gravity scale equal to 0. Okay, cool. And then he moves the rigid body. How does he do it? He does rigid body dot velocity, and I think this is how he does it. Equals vector, no, equals new vector 2 transform dot local scale dot x on the x value, multiplies it by the dash power, cool, and then leaves the y value as 0. All right, then you yield, return, wait for seconds, wait for seconds, dash time. Okay, again, the dash time is the amount of time that you want your player to be allowed to dash. Yield return new. Wait for seconds. Yield return. Oh, new. You need the word, the keyword new. He also turns on the trail renderer. So dash trail dot emitting is equal to true. After that, 0.2 seconds, that's how long we're going to dash. We then set the trail renderer dot emitting to false. So we turn off the trail renderer. We don't want it to stay on. We set our gravity scale equal to the float he declares inside this function. So we set it to the original gravity. So basically what he's doing is he's getting whatever the original gravity is on the rigid body, and he's setting it to 0. But he's declaring, he's storing that value inside this float for this purpose. He's storing it in there. What does he do next? And then we're doing is dashing set to false, because we're not dashing anymore. We're stopping the dash. Then we're going to wait a little bit longer. This is the cooldown time. Yield, return new, wait for seconds, not end of frame, wait for seconds. And that'll be our cooldown time. Dash cooldown. Oops. After our dash cooldown has completed, after our 1 second has gone by, we return the Boolean can dash to true. So now we can dash again because we've waited our 1 second. Okay, boom, and I think that's it. So this is the enumerator, and we're calling the coroutine in our dash button function here. So that should work. One thing we have not done yet, which will pop an error, and I just want to take care of it before I push play, is that we haven't added a trail renderer. So we're going to add a trail renderer. And I have a preset color here. I like this. I just think it looks cool. do whatever color you want. So we're going to add that color. The time 0.5. We don't, so this emitting, you got to uncheck that because otherwise it'll just constantly be emitting. We want it to emit through code, which was what we did with the trail renderer.emit, and then assign a material to it. We're going to use sprite default. And that should be it. So let's push play. So he also did in the update, we said this is something he does, and this makes sense. So in the update and the fixed update, if is dashing is true, then we want to return. We don't want to go any further because we don't want to be able to jump and do anything else because we're currently dashing. So all right, let's see. Is dashing start if and dash start coroutine dash. Oh, the other thing is that we have to say that at the beginning of the game, or when we first turn him, have to enable this script, we have to say can dash is true. Let that update. See if our player movement. We got our dash stuff, dash gravity. Okay. All right. It's not dashing. What did I miss? All right. Stand by, please. Oh, you know what it is? It's because right here, because I keep doing this with everything, I keep forgetting that on the input, we have to assign the dash to right here. So again, let's take that player movement script, bring it down, player movement, and then dash. Now it should work. Whoa, look at that. All right, so let's alter. Now, I've messed around with this. I think this is pretty cool. For the trail renderer, you're going to bring that down. You want it to be bigger at the start and thinner at the end. But I even take this, and I like to go down below the graph there. And that's my personal preference. I just think it looks cooler. What you think looks cool and what I think looks cool, Now look at this. So this is one thing that I noticed using when you use his code. All right, when you use his method, Bendux's method of dashing. And this applies to pretty much every video out there. You can see that I can dash, but if I'm moving to the left, I'm not dashing in the left direction. And that's because, the value that it's moving in the dash function is transform.localscale.x. So basically, if you go, because remember, our movement is using the new input system. So it's reading a value, and even though the movement value is going to the left, the dash value is only doing the local scale. And in his video, he sets his local scale based on his flipping. So let's implement our, let's do our flip. Let's do the flip. So in the update function, you should always be checking for what direction you're facing. So let's create a function called check direction. All right. And let's go down here and make a check direction function. This will make sense here. Just follow along with me. So check direction. We're going to say, so in ours, we're doing a move vector. And we have to determine if we're facing right or facing left. So we're doing if our move vector dot x value. All right, is that how I do it? Let me see what I've done here. I think that's what I did. Yeah. All right, cool. If our move vector dot x is greater than 0 and we are not facing right, then let's flip, which is another function. And right here we're going to do void flip. And for the flip, we're doing kind of like that pause boolean. It's the same thing. Is facing right equals the opposite of is facing right. Okay. And then we're going to take our transform and we're going to rotate it. New vector 3. Rotate values on the x is 0. We're going to rotate 180 degrees on the y and 0 on the z. Okay, so that's how we flip, and then we have to also say else if our move vector dot x is less than 0 and we are facing in the right direction. Oops. We'll also call the flip function. So this is standard. This is the standard way of anybody who wants to do, the flip. This is pretty much how you do it. Now, you'll see in his video, he does his flip a little bit differently. I don't want to get into that. That's not the purpose of this video. So just know that this is, in my opinion, obviously, I'm not a coding god, but this is a better way to do it. So he is moving the transform right here on the dash function in the local scale.x. Now, since we are moving our vector, this should work to now dash in the direction that we're moving. I think. Okay, we're moving right, we dash right. Nope. You see how it still goes back? Okay, that's one issue with that code, and it's because we're using the new input. This is the only thing I've deduced, is that it's because we're using the new input system. We're not using horizontal, vertical. We're not using the old input system. Okay, so I needed to create a video that shows you how to do it using the new input system, as well as if I'm not moving. Oh, it does do it. Okay. Wait. Move X. Okay. I'm jumping ahead of myself here. I'm trying to think. If you use the new input system and go with his code, I think Move vector, because right here, transform dash, can dash. Okay. All right. Well, it's beyond the. It doesn't matter. So let's get back to this issue. So the initial issue was, or this issue is that it's not dashing in the direction that I'm going because we're using the new input system, and it's only reading a positive value on the local scale. If you go up here to the top of the inspector and you click on debug, you can actually see the local scale right here on the X value is set to 1. Okay. And do you see how no matter which way I'm moving, it doesn't change? If I'm moving left, you would see the local scale going negative. But it's not. It's not going negative. Because in the code, he's just reading a positive transform.localscale x. Okay. If I were to change that to negative and go back, it'll read the local scale as 1, but now apply it in a negative direction. So now I will go in the negative direction. So anyway, so we need to fix that problem, and using the old input system or using it how he was is not allowing you to do that. So because when you use the new input system, it's reading whether you go left or right. Let's see, player movement. It's move vector. So you see this move vector here? This is the new input system that we're reading. We're reading this value when we move. So let me push play, and hopefully this explains it. So when I go to the right, that move vector becomes 1. When I go to the left, that move vector becomes -1. But in the dash code, it's not reading the move vector. It's reading just the transform local scale, which doesn't change. So, oh yeah, because I set it to negative. All right, let's change that back. Let's fix this. Okay. So we're gonna modify this, and we're gonna make it work with the new input system. I think if it was flipping, anyway. All right, so let's do it the way that I figured out how to do it with the new input system. We're going to take away the coroutine because, like I said, I didn't want to completely copy someone's code. So that's what I was trying to avoid doing here. But I do want to give credit where credit's due. This guy, Ben Dux, did this code right here. But we are going to completely get rid of that. And we are going to do it this way. We'll get rid of that coroutine. We don't need that in there. So that's why I did a invoke. We'll go down here and we'll do public void dash. Okay, and now we will use our variables. We want to say can dash equal to false, is dashing equal to true. Our dash trail, we want to turn it on. And then right here, I call our dash gravity. So we set our gravity scale, our rigid body's gravity scale. So this is similar, but to what he did, but not. So we set our gravity scale to what our dash gravity is, which we assign. Remember up here we go. We have a serialized float of dash gravity. So you'll assign that to whatever you want it to be. Now we have this normal gravity also. You'll see where that's used down here. Now this is where I couldn't find a video that basically moves you from the standstill using the new input system. So that's where this section comes in. So if our move vector dot x is equal to 0, meaning that we're not currently moving, if we are facing right, then we want to set our velocity, rigid body dot velocity equals, let's see, new, what did I do? Hold on. No, yeah, this is it. All right, new, where is it? All right, so our velocity equals a new vector 2, and we're going to take the positive direction of our local scale, transform. So similar to what he did, local scale on the x value, and we're going to multiply it by our dash power. Cool. Then, let's see, and then else if, no, just do an if statement. If we are not facing right, meaning we're facing left, rigid body dot velocity equals new vector 2. Now this is where we'll apply the negative. Dash power, leave the y alone, and then outside of this if statement we'll do else. Okay, so if that first section right here, this is if we're not moving at all. If our move vector is not moving, then we can dash from the sit still using this. Else, if we are moving in a right or left direction, then we just set our rigid body velocity equal to new vector 2, our move vector, whatever value we're reading, dot on the x value, and multiply that by a dash power. Okay, hopefully that makes sense. And then since we're using an invoke, we have to stop the dash. Otherwise, see, if we just do what we have now, it'll just dash forever. It'll just keep going. Oh. Hold on. Do I have this? Let's go back to normal. We don't need to be in debug right now. Dash gravity. Dash. Void dash. Invoke dash. Oh, you know what? It's because we didn't assign the... See, I'm jumping all over the place. It's because this wait time hasn't been declared. So in update, we have to say wait time is plus equal to time dot delta time. Whoa. Okay, so he keeps dashing. If you, I don't know if you saw that. So move and bye. All right. So we don't want that. So we got to be able to stop it. So when you do an invoke for something like that, you have to call another function that will stop the dash, which is essentially what you did in the coroutine. Stop dash. Okay, and then in the stop dash, we'll basically call the second section of that coroutine where we turn everything off or on or make it the opposite. So can dash will now be true because we're not dashing anymore. We'll set our is dashing to false because we're not dashing anymore. We turn the dash trail renderer off, so we don't want that to play forever. And then here's where we set our normal gravity. We set our rigid body's gravity scale equal to our normal gravity. And then that is it. So that'll, oh, and then we have to call it. So in our invoke dash, now we will call invoke stop the dash after our dash time, which is what we assign in the inspector. So go over here, let it compile. Okay. All right. So that's how you do it with the new input system. All right. Did I set that to, yeah, so 1 second. So every 1 second I can dash, and if you can see here, I'm dashing from the sit still. I can also jump, I can move and dash, but I can't spam it. Now if you want to be able to spam it, you take that cooldown and just put it to 0. And now I can spam the dash. But I don't want that for my purposes. So now you can dash from the sit still, as well as it implements the new Unity input system to accomplish the task. So again, hopefully this video helped, even if it just helps one person understand how to dash using the new input system and from the sit still, then I've accomplished my goal. So that is it for this video, guys. Thank you so much for watching it. And please, like I said, this is my first video. Please leave me some constructive criticism on what you think I can do better in my next video. Thank you, and have a wonderful day.